Hello class, today we are taking a look at some guided practice for solving two-step equations. In our handout, question A, we have 2x plus 1 equals 7. We already have the left side of the equation drawn for us. So we have our two x tiles. Each long skinny rectangle is an x tile, so two of them together is two x's. Then we also have our one positive constant already drawn on the left side. So first thing we want to do is we want to go ahead and draw the constants on the right side in two rows. We know we're going to do two rows because we want to match our two x's that we have. So I need to draw 7 total positive constants on the right side. And again, I'll draw those in two rows. That's 2, 3, 4, 5, 6, 7 positive constants on the right side. Next thing I need to do is I know I need to isolate my x's, which means get them by themselves. And this wall here is what separates them from other things. Unfortunately, we have this positive constant with the x's on that left side of the wall. They don't want that positive constant with them on that side of the wall, so we're going to go ahead and get rid of it. So we ask ourselves, well, what cancels or forms a zero pair with this positive constant? Well, it's going to be one negative constant. We know a positive and a negative cancel out as a zero pair. However, if I only add that extra negative constant to the left side, I've changed my equation. So I need to make sure that I also add a negative constant to the right side. I'm going to do those in red, actually. And cross out a zero pair there as well. Now, after I've crossed out any zero pairs, I can circle the value of 1x, which will be one row. So I can see that this x matches to 3 positive constants on the other side, and this x here also matches to 3 positive constants on the other side. So I can say my solution is that x is equal to 3. In terms of my symbolic work, I want to start by identifying where my x is, because that's what I need to focus on in terms of what is being done to it. Right now my x is being multiplied by 2 and added to by 1. And we remember that because we are undoing this calculation, we need to do it in reverse BEDMAS order. So we're actually going to undo that addition first. So I want to ask myself, what's the opposite of adding 1 to x? Well, that's going to be subtracting 1. And whatever I do to the left side, I must also do that same solving operation to the right side as well. Now on the left side, positive 1 and minus 1 cancel out with each other. We do still have our 2x on that side. On the left side, we have a calculation that we can do, and 7 take away 1 is 6. And of course, those are equal. Next thing to undo is our multiplication. We know that a coefficient in front of an x is multiplying by that x. So we want to ask ourselves, what is the opposite of multiplying by 2? Well, that's going to be dividing by 2. And as usual, whatever I do to the left side, I must also do to the right side. Notice how in each solving step, I have exactly the same thing written on both sides of the wall. Okay, I do still need that dividing by 2 there. 2 divided by 2 cancels out, leaving us with 1x, which of course is just x. And on the other side, 6 divided by 2 gives us our solution of 3. And of course, notice we did get the same solution from both our symbolic and our algebraic work, which is a good sign that we did in fact do them correctly. It's the same question, it should have the same solution. In question B, we have 3 equals 4x subtract 5. So we do already have our 4x's, 1, 2, 3, 4, drawn for us to the right of the wall. And then we also have our 5 negative constants, 1, 2, 3, 4, 5 unshaded negative constants. Now we do still need to draw our 3 positive constants on the left side. And so I'll draw those in, trying to match them up into rows with my x's. Okay, now in order to isolate, I want to look for where my x's are. They're obviously on the right side of the wall, and that means I have to cancel out these constants that are with those x's. So in order to do that, I'm going to need a total of 5 positive constants, and I'll draw those in red to form zero pairs. We'll cross those out. Now, of course, if I add 5 red positive constants to the right side of the wall, I'm also going to have to add a total of 5 to the left side of the wall. So that's 1, 2, 3, 4, 5. to make sure I'm doing the same thing to both sides. Nothing on that left side cancels out because we don't have any zero pairs. That's all good. Last thing to do is to circle the value of my 1x, so I can see that this x matches to 2 constants on the other side, this x matches to 2 constants, this x matches to 2 constants, and this x matches to 2 constants. So every x that I have on the right side matches to positive 2 on the left side, and that's going to be my solution. When I take a look at my symbolic work, I again want to start by identifying where is my x. It's right here in my equation. X is currently being subtracted by 5 and multiplied by 4. Working in reverse BEDMAS, we're going to undo that subtracting 5 first. So what's the opposite of subtracting 5? It's going to be adding 5. And of course, we add to both sides of the equation there to keep things fair. Minus 5 and plus 5 on the right side cancel out, and 3 plus 5 on the left side leaves us with 8. On the right side, we do still have our 4x. That has not yet canceled out. Now again, we know that that 4 is currently multiplying by x, so we need to undo multiplication by 4. The opposite of multiplying by 4 is dividing by 4 on both sides of the equal sign. 4 divided by 4 on the right side cancels out, leaving us with 1x, which is just x, and 8 divided by 4 on the left side is 2. And again, we get that same solution, x is 2, x is 2. Okay. Notice from these two examples that it does not matter which side the x is on in the equation. You just need to focus on that side in terms of your work, right? So that's why it's really important to think about where is the x, which side of the wall is it on. On the back there, we have some questions that are giving you a little bit less help in terms of starting them. So question C, we got 3x minus 2 equals 10. We're going to draw our wall. I have 3 x's, so I'm going to draw those 3 nice long skinny x tiles. There's 3 of them there. And I also have 2 negative or unshaded constants. And on the right side, I have 10 positive constants. And I'm going to try to sort those into 3 rows. So it's 3, 4, 5, 6, 7, 8, 9, 10 positive constants there. Okay. To isolate my x's, I need to get rid of these 2 negative constants, which are bugging those x's, hanging out with them. So what cancels with 2 negative constants is going to be 2 positive constants. And of course, what I add extra to the left side, I'm going to have to add extra to the right side as well. Since everything on the right side there is positive, and there are no zero pairs on the right side. Last thing to do is say what each of my x's is worth. So this x is worth positive 4, this x is worth positive 4, and this x is worth positive 4. So I have the solution x is equal to 4. In terms of my symbolic work, here is my x. Currently it is being subtracted by 2. The opposite of subtracting 2 is adding 2. I'll do that to both sides of the wall. On the left side, minus 2 and plus 2 cancel out, leaving us with 3x. On the right side, 10 plus 2 is 12. Now we know that 3x is 3 multiplied by x. The opposite of multiplying by x is, multiplying by 3 is dividing by 3. And of course, we'll divide both sides by 3 there. 12 divided by 3 on the right side is 4. And 3x divided by 3 is just 1x, which is just x. In question D, we've got 7 equals 5x subtract 3. Draw our wall. I'm going to start by drawing those 5 x's. 1, 2, 3, 4, 5. We also have 3 negative constants there. Throw those in. And then with our left side, we've got 7 positive constants. So 1, 2, 3, 4, 5, 6, 7 positive constants. I need to get these x's by themselves. Right now, those x's are being bothered by these 3 negatives that are on the same side as the wall as them. So what cancels with 3 negatives is 3 additional positives. And if I place 3 extra positives on the right side, I have to be fair and place 3 extra positives on the left side as well. Again, we're going to circle. So we've got 2x is equal to x, 2 constants is equal to x. And of course, that's true for all these rows. So we know that x is 2. In my symbolic work, here's my x. It's currently being subtracted by 3 and multiplied by 5. We want to undo the addition or subtraction first. So the opposite of subtracting 3 is adding 3. And of course, we do that to both sides of the wall. On the left side, 7 plus 3 is 10. And on the right side, minus 3 and plus 3 cancel out. We do still have our 5x. We know 5x means 5 multiplied by x. The opposite of multiplying by 5 is dividing by 5. We'll divide both sides by 5. 5 cancels with 5, leaving us with just x on the right side, and 10 divided by 5 on the left side is 2. And again, we have that same solution for our equation. Last one here is 3 plus 2x is equal to 7. So we'll go ahead and start by drawing our two x's here. Sometimes people get freaked out by that x being the second term, but really it doesn't matter. We also have 3 positive constants. It's definitely not minus 3, so it's 3 positives. On the other side, 7 positive constants, and we'll sort those into our 2 rows. 4, 5, 6, 7. That one got a little bit special there. We need to get our x's by themselves. Right now they're being bothered by these 3 positive constants, so what cancels out with 3 positives is 3 negatives. If I place an extra 3 negatives on the left side, I must also place an extra 3 negatives. 1, 2, 3 on the right side. We'll cross out some 0 pairs there since we have them. We're going to finish up by saying what each of our x's is worth, and we can see that that x is worth 2, and the top x is worth 2 as well. So x is 2 is our solution. In terms of our symbolic work, you want to look carefully. Here's our x. It's being multiplied by 2 because it's touching that 2. We're also adding positive 3 to that x part. So first thing we want to do is adding 3. The opposite of adding 3 is subtracting 3, and we'll subtract 3 from both sides of the wall. 3 cancels with 3, leaving us with 2x. And on the right side, 7 take away 3 is 4. Last thing to undo is the multiplication. 2 is currently multiplying by x. The opposite of multiplying by 2 is dividing by 2. 2 cancels with 2 on the left side, leaving us with x. And 4 divided by 2 is 2 on the right side. And of course, same solution from our equation, both symbolically and pictorially. So I hope that's helped with your two-step equations.